Welcome to this IEA workshop on energy efficiency policy and digital tools. My name is Nicholas Howarth, and I'm policy analyst here in the IEA's Energy Efficiency Division, and I'll be your moderator for today. Before we get underway, a couple of quick housekeeping notes. Next slide, please. For our online audience, please give us your questions and comments via the chat option at the bottom of your screen. For panelists, during your panel discussion, please raise your hand using the reaction option during the panel discussion. Next slide, please. During this workshop, we have a great lineup of panelists from a diverse group of countries from around the world across 2 sessions from both business and government to discuss how digital technologies can support energy efficiency policies and programs. A special thank you to those of you joining us either very early in the morning or late in the evening. I will now hand it over to my colleague, Brian Motherway, head of the IEA Energy Efficiency Department, who will briefly introduce the work of the IEA on the topic. Brian, the floor is yours.
Thank you, Nicholas. So good morning, good afternoon, good evening, everybody. Let me add as well on behalf of all of us here at the IEA, our welcome. And I thank you very much for joining us for this webinar. I think it's going to be a fascinating discussion, and I really want to thank all of our speakers for giving their time to join us today. We sit here very much in the context of higher climate ambition. The last year has seen really dramatic and very welcome stepping up of ambition for net zero commitments in energy systems and from governments around the world. This, of course, is to be lauded. But of course, making such a commitment is one thing, delivering it through policy action is another. And some of you may have seen that recently we published a net zero emissions by 2050 roadmap, which is just one way of envisioning how we get from where we are today to a net zero global energy system by 2050. You'll have seen, if you saw that roadmap, that it requires a huge amount of policy action starting right now in every technology, every sphere, every sector, and of course, every part of the world. It's not an easy pathway, but it can be done if we all work together to deliver the policy action and the responses, and of course, the investment necessary. You'll have also seen that energy efficiency is front and center here. It's one of the strongest actions across the decades, particularly in this first and crucial decade between now and 2030. By 2050, we could see a global economy that has more than doubled. We could see additional 2 billion people on the planet. And yet, driven by energy efficiency, the global energy system could actually be smaller than today in terms of its demand. Now, to achieve this, we would need to see, particularly in the first decade, a massive scale up of energy efficiency progress, approximately 3 times the annual rate of energy intensity improvement that we've seen in recent years. We believe this can be done. We know the technologies and solutions are there. We know the policies are available for governments to look at, but it really will require a major step up of action. The question, of course, today is how can digital tools help with that? I think our starting point is there is huge potential here, huge opportunity opening up, not just for how consumers interact with digital tools, but of course for policymakers themselves in terms of making the design, the delivery, the follow-up of policy measures easier, more efficient, and more effective. And today we'll hear a number of examples of really promising and really impactful areas that this is already happening. And I hope it'll give you a sense of what the future potential is to really open that up. So the question is what is possible, but also how to get there. So we really want to talk as well about if policymakers want to exploit these new tools, if they want to avail of the innovative business models, solutions, technologies, AI methods that we're going to hear about today, what do policymakers need to do in terms of readiness to exploit these opportunities, to allow them to play in the market, but also to handle the risks and uncertainties, risks related to cybersecurity, public acceptance, privacy, data ownership, and the many challenges that will be there. So we're really hoping that today we can have a rich discussion about both the positive sides, but also the challenges and the necessary actions. I want to tell you that the IEA is really focused on this issue. We really believe that energy efficiency is changing for the better through digitalization, and energy efficiency is entering a new golden phase where it can really help step up global ambition and progress towards net zero, while also delivering benefits, including job creation, more resilient energy systems, cleaner cities, better quality of life, lower energy bills for all. Energy efficiency is absolutely essential to all of our net zero pathways. So we really want to hear from you during this workshop, and afterwards, please get in touch. And particularly, I want to thank the Government of Canada, and if I could pass on our thanks to all of our NRCan friends for the support for this workshop and for ongoing work. We really appreciate your support. So with that, let me hand back to the chair, and I look forward to hearing the discussion today. Thank you, Nick.
Thank you, Brian, for those opening remarks. I'm now happy to invite Dr. Vic Pant, Chief Scientist and Chief Science Advisor from Natural Resources Canada, who have supported this workshop, to make some further introductory comments. Thank you, Vic.
Thank you very much, Nick, and also thank you very much, Brian. It's my pleasure to be here, and also great to be with so many distinguished panelists and co-presenters. It's really great for NRCan to be able to support such an important initiative. Next slide, please. So one thing I'd like to talk about is, by way of background, at Natural Resources Canada, we focus on energy, forestry, and mining. And really one of our goals is to ensure that our stakeholders in these industries, in Canadian industries, in these sectors, can be competitive, can be productive, and can be innovative on a global stage. And what that means is certainly there is an economic aspect to that, but there is also an important environmental aspect, as Brian just touched upon, the importance of net zero commitments, as Brian touched upon, the importance of looking at climate change as a way to address energy efficiency as a way to address global climate change issues. And really the important thing here for us is that energy efficiency is that bridge. If you look at some of the value constellations, value ecosystems within the climate tech space that touch upon the portfolio that we manage within NRCan, there's many elements to it. You can think about the built environment, you can think about elements of heavy industry, energy, mobility, buildings, land use, and water. And this is just areas where NRCan looks at, and you can already see how many opportunities there are for energy efficiency within them. Now, in Natural Resources Canada, one of the things we did to ensure that digital technologies could truly be taken advantage of by stakeholders in this sector, we set up the Digital Accelerator, which is a very interesting initiative that brings together our policy leaders, our science experts, and our digital technology experts, such as data scientists and digital solution architects, computer programmers, software engineers, all together into the center of excellence, where they can really think about creative applications of innovative technologies to advance science and policy integration, with a goal of ensuring that not only are we improving the competitiveness, productivity, innovativeness of our sectors, but doing so in a way where energy efficiency is the common thread that's linking the environmental goals to the economic goals. Quick idea around the Digital Accelerator. Now, we've realized, having been doing this for about 18 to 20 months now, is there are a few things which we're happy to share with you that we found have been truly helpful to not only launch the accelerator in NRCan, but also to scale it. The first is to ensure that even though we have the center of expertise, where we bring together data scientists, together with our policy leaders, together with our science experts, we can't do that in a silo. We have to ensure that there are opportunities for knowledge sharing and collaborative learning across our department as a whole. So indeed, not every colleague within NRCan becomes a digital expert, but nonetheless, we need to do things to ensure that collectively we can elevate the digital quotient and the digital acumen in our department. So to do that, we organize a number of knowledge sharing sessions, a number of Ask Me Anything sessions with our experts, lunch and learn sessions, birds of a feather sessions. So really creating the environment around the core digital acceleration initiatives to ensure that collectively the understanding of what digital offers in the context of energy efficiency is something that all of our colleagues in the department can understand and can get behind. The second piece of it, which is I think very, very important, is to talk about the power of partnerships, which is why the great work that the IEA does, and also this kind of a knowledge sharing opportunity is tremendous, because we know that nobody knows everything and everybody knows something. So we have entered into very interesting partnerships, for example, with Microsoft, where now Microsoft and NRCan are working together on a number of interesting sustainability and a number of interesting energy efficiency type projects, where it's not simply just Microsoft providing us software and us compensating them for the software, but really bringing their thought leaders together with our thought leaders, with other thought leaders from our larger ecosystem, to ensure that we can co-create value and advance our goals in a symbiotic and a synergistic manner. And then the last piece I want to touch on is the importance of governance, because after all, within government, we have to ensure that we are conducting ourselves with the highest levels of transparency and holding ourselves to the utmost degrees of responsibility and accountability. So ensuring that all the work that's happening in the digital accelerator can happen in a way that is within the rubric of our governance mechanisms, of our compliance structures within the department. I think that's really helped us to advance the application of digital technologies to the progress of energy efficiency in our own department, but also ensuring that this can be something that our sectors can benefit from as well. So with that, Brian and Nick, thank you very much for the opportunity, and I'd like to pass it back to you.
Thank you very much, Vic and Brian, for the scene-setting remarks. I'd like to jump now straight into the next panel session, which will focus on how digital tools such as big data and analytics can equip policymakers with a new level of energy use information that has previously been difficult and costly to obtain. It's now my pleasure to introduce the wonderful lineup of keynote speakers for the first session. We will start by welcoming back Dr. Vic Pant, Chief Scientist. The floor is yours. Thank you. We look forward to hearing more about how Canada is progressing with the digital tools experience.
Thank you. Thank you very much again, Nick. And again, great to be here with yourself and with Brian. Next slide, please. So one thing I'd like to talk about is a specific illustration. And this is one of many, many illustrations in Canada. We're very proud of the great work that is being done in applying digital technologies and solutions to advance energy efficiency. But I thought that this would be a good exemplary case because it really brings together elements that were listed in my previous slide. So here we have an organization called NR Model Group, which is an engineering organization who focuses on helping organizations to build and to operate LEED certified and green eco-conscious buildings. And at NRCan, one of our goals is to ensure that when it comes to energy efficiency and when it comes to the broader net zero commitment we have, as well as fighting climate change is concerned, that we're really operating on 3 pillars. One of them is to encourage responsible consumption, making sure that people are consuming in a responsible way. The second piece of this is ensuring lean production, because we know that aside from perhaps inoptimal utilization on the consumption side, sometimes there are also excess production and then overcapacity and things like that, which also lead to perhaps energy that could have been captured and used for other uses being applied to uses which will not really create value. So the notion of lean production. And the third piece is essentially conscientious stewardship, and all of this to make sure that where we have the opportunities, we're able to recycle, renew and reuse sources of energy that we can use to then power our lives and power our work. So NR Model Group, which is now a part of an organization called WSP Group, built this building a few years ago. And because they're experts in green buildings and they're experts in LEED certification, what they wanted to do was to ensure that their building was really energy efficient at the highest levels possible. And they did so using some fairly innovative techniques, which not only helped them to achieve their environmental goals, they are a very eco-conscious organization, but also it made sense from an economic perspective. And I think that is the important thing to really convey in this workshop, is that yes, digital technologies entail an investment, and yes, indeed, being energy efficient may require some upfront costs, but in the long run, when you cost this out right, what you actually found is that the business case, the economic case is just as strong as the environmental case. So for instance, what they did was by leveraging state-of-the-art advances in technologies such as artificial intelligence, Brian touched upon that, smart sensors and the Internet of Things or the Internet of Everything, and using technologies which now are getting very prominent around smart ledgers and decentralized ledgers, etc. They were able to build this building, which essentially is extremely efficient to operate on a cost per square meter perspective, from a construction cost perspective and from a long range operating cost perspective, using a array and assembly and network of smart sensors. They're able to essentially monitor how the building is operating in terms of climate control at different parts of the building. They can then feed that information into their HVAC, or their heating, venting, and air conditioning system, control system, and essentially ensure that the building temperature can be regulated and monitored, not simply based on somebody turning thermostats as they wish, but also ensuring that there is a sophisticated logic driving how the building optimally has the right climate profile, ensuring that they have the right type of mechanical systems in place, interfaced with the right type of artificial intelligence devices in place, that when the wastewater coming from the flushes, coming from the sinks, can be captured and can be renewed for other uses. In the server room, for instance, where for many organizations today, a lot of heat is created as more servers are added in and more CPUs are added in on the servers. And so then venting that kind of heat from the server room, adding that into a heat pump and using that to meet their water heating needs. So lots of interesting sort of innovations were applied when this building was built, with that foresight that technology, especially software technology, can be upgraded modularly. And also now, if you use elements which are from the physical world, such as you have 3D printing based modules or components or prefabrications, you have advanced manufacturing techniques through which you can build these very reusable prefabricated elements of buildings that you can swap it and swap out, perhaps not as easily as software, but nonetheless, as you can still swap out. You really have a building that has been built with a view of sustainability in mind. If the building grows over time, it can be fit in such a way that, of course, that all the current operating gains of energy efficiency can be applied and preserved through time, but also just ensuring that, as I mentioned before, that, you know, when it comes down to it, a lot of building operators and building owners, they think that, okay, we're going to have to make a huge upfront investment to make a building that is energy efficient. But as Brian noted earlier, the application of these digital technologies is becoming so commercially viable nowadays that, in fact, the environmental case is very well balanced with the economic case as well. And I look forward to engaging with colleagues on these kinds of cases as we go through the rest of the presentation. So thank you very much again, Brian and Nick, and back to you.
Thank you, Dr. Pan, for that excellent case and overview of how digital tools are being applied in Canada. I'm now very happy to introduce Ms. Yuzhuang Xia from the China National Institute of Standardization. Please, you have the floor.
Good morning, good afternoon, and good evening, everyone. I'm Xia Juan from the China National Institute of Standardization. It's my pleasure to share some information about the digital tools application in China Energy Living Program. Next slide, please. Here is a quick review of the eligible registration process. Firstly, the manufacturer needs to obtain a testing report in required format, and then they need to upload the EE testing report and fill other required information in CL implementing rules. And then the database can generate the QR code randomly, which can be downloaded by the manufacturer and be used for making and printing a label. And finally, after label registration, the registered information are made available to public through the CEL website, and the QR code can be scanned using phone, such as using the scanning function of the WeChat app. Next, please. Next slide. Thank you. For the label registration, the needed information is defined by the CEL implementing rules. And the next slide. For a specific product, Usually, there are only several parameters required to be displayed on the label, such as for the room air conditioner, there are only 5 parameters required. Next slide, please. But for the label registration, there are more than those displayed on label are required to be submitted. Here we give a tip. You can see there are a long list of information, except for the core indicators marked by the blue rectangle. There are many other information required. Next slide, please. Next slide. Next slide, please. Next slide. Such as the refrigerant type and the filling quantity. So, a lot of information means more possibilities. Next slide, please. For the benefit of the registration database, we think there are mainly 2 points. Firstly, the information for product models registered can be output in Excel format, and statistical analysis can be carried out conveniently to provide information on market share of each EE grade and the market share of each subcategory for a specific product, and also the year-to-year evolution of energy efficiency for specific products. And also the information can provide a reference for policymaking and EE standards revision. Next slide, please. And for the QR code application, we think there are several benefits. Firstly, the QR code allows for providing more information than those included in label. They are not called energy efficiency indicators, but they are important for consumers and market surveillance, such as the resolution for TV, the refrigerant for ACs, and the refrigerators, and so on. Secondly, the QR code allows for further data development to better guide consumers in purchasing, such as based on EE parameters and the refrigerant information. We can provide information about electricity usage and CO2 emission based on some assumptions and calculation. And also the QR code can allow for providing more information about whether the product has got other certifications, such as some green product certification and so on. Next slide, please. And also with the QR code, it can allow manufacturers to display product manual and guideline for using appliances. With these things, they can help for users to find the manual conveniently and may help to save paper resources. And also more product information for consumers can help them better understand the target product and save energy during usage. And also the QR code can help for market surveillance. It makes it possible to obtain registered information in real time with a smartphone only, rather than logging on a labeling website with a laptop. They can help officials to find out whether the product has registered and whether the registered information is consistent with the attached label. So this can significantly improve the convenience and the timelines of surveillance. Next slide. Next slide. Oh, okay, that's all. Thanks for your attention. Thank you.
Thank you, Yuzhuan. And it's great to see, China is really leading in consumer adoption of a lot of aspects of the digital economy. And it's great to see how policymakers are leveraging such information from the QR code-based standards and labels program. Next, I'd like to move to Mr. Gabriel Flano, Head of Sustainable Energy Division of the Ministry of Energy in the Government of Chile. Please take the floor.
Thank you very much, Nicolas. Had an updated version of the slides, but they're not too different, so I guess I can go with this ones. So first, you can go straight to the next slide. You may hear several times about the 3Ds that are needed for energy transitions or for energy modernizations. In that sense, decarbonization, decentralization, and digitalization play an important role. In the case of Chile, Chile actually has committed already to be carbon neutral. It's actually the first developed country to commit to be carbon neutral by 2050 and has a strong agenda to achieve that, sustained in several pillars to achieve that. Of course, I will not get into details about that today. In decentralization as well, we have seen an important growth of the distributed generation and how people are creating their own generation as well. And in digitalization, we have doing some work as well that I will show you a bit today, and I perhaps will summarize about it in of the results of a study that we finished recently. And if we go to the next slide, I will quickly summarize about why it's important to talk about this and what are some of the benefits that we see. First, some of this was mentioned already. We can get better and more information from this, and that can help us to enhance our analytical capabilities to conduct better policy evaluations. We can also have more transparent and competitive markets, and we can also optimize production and reduce costs in our overall way. We can also optimize our processes, and thus will help energy efficiency across different uses. Process optimization, it will be also key. Also helping efficiencies from different enabling technologies, and flexibility and coordinating energy systems will also help us to develop renewable energies. And in that sense, it's important also to mention that we face an important challenge of having a more end-user focused paradigm in our energy systems. And in that sense, digitalization is an important rule that will allow us to develop this. In the next slide, I briefly mentioned the study. Basically, its name is a study, Prospection and Energy Utilization in Chile. It has two main contents. First, we did a review of the national and international state of the art of digitalization in the energy sector, and then we analyzed specific barriers and opportunities for the case of Chile as well. On the next slide, I will mention here that it was some of the barriers and opportunities that we perhaps analyzed. You can group them perhaps in 5 main categories. First, in infrastructure, it's important to develop enabling technologies for deployment of different digitalization users. In security, we do need protocols and regulation for privacy, data sovereignty, and information security. In economics, important investments are needed for the implementation and deployment of the infrastructure, and the investment costs for both from the private and public sector may be needed. In the case of regulations, several parts of regulations may be needed some update as well. And in training and capacity building, it's important as well to create the right knowledge and to update knowledge to basically encourage different professionals and technical people as well to have the digital education that is needed for this. In the next slide, I briefly mentioned, I will actually skip this, the study analyzed 30 different applications that were distributed in these 8 categories. I will not mention them here, but basically their uses are along different sectors like transport, industries, or buildings. Next slide, I show the different enabling technologies that were analyzed as well, and they go from smart and whole buildings, smart grids, IoT, IoE, big data, machine learning, artificial intelligence, blockchain, and also how physical actions can also enable some digitalization in the energy sector. I think my almost last slide in the next one is to mention, one issue before some policy recommendations that came from the study. I'll go quickly through them. Basically, and they're not only for Chile, so perhaps this is something that could be also used in other parts. So how it's very important to promote the coordination between different institutions. Not only something that will happen from the energy sector, but how we need to coordinate with different institutions will be key. How we need to increase the investment in infrastructure to build a robust ICT infrastructure, how to adopt a common data architecture tools and standards will also it will be key to have some interoperability in our systems as well, and some reliability and security as well. This is a very important topic as well that's not always addressed to the importance of reducing the digital gaps between territories in the countries, and also how we need to increase the human capital and education. Pilot programs and private investments are also part of what we need. Just to finish up, perhaps we can get more details about this later in the last slide. I want to mention an experience in Chile. We were in the process of rolling the smart meters in Chile. And actually it had some problems because of the communication, and this is why we believe this is very important to communicate the different benefits that digitalization may have in the system. They're not always easy to understand, and it's very important for that. In the case of Chile, it happened that people didn't want the smart meters because of the little cost that they added to their final bill, and they didn't perceive the benefits of this, and at the end, the acceptance was so low that actually we had to slower our implementation of that. So with that, I want to finish here and look forward to the questions later.
Thank you, Mr. Flano, and that's a great insight into towards how Chile is moving towards a more user-focused energy system with smart meters and distributed demand-side resources. I'm now pleased to welcome Rebecca Knights, Director of Energy Policy and Programs at the Department of Energy Mining in the Government of South Australia. Please go ahead.
Thanks, Nick. If I can go to the next slide, please. I thought I'd take this opportunity to talk about how data and digital tools are informing and enabling a shift in policy here in South Australia. So in this first slide, I provided a bit of context. So you will see from the data analysis that our market operator is doing, we're not only looking at peak demand on our system now, we're really highly focused on minimum demand. So this chart is actually showing the demand that's met from grid generation. So it's excluding demand that's met from distributed energy resources. And you can see, because we've been highly successful in solar, rooftop PV, that we're actually tracking towards periods where the whole of our demand can be met from distributed resources rather than from grid sources. Now, this has meant that our market operator has really had to shift their analysis and is using data and dynamic models to look at how this new paradigm actually impacts system security. And it does have system security issues because your rooftop PV really becomes significant in how you manage a disturbance on the system. Next slide. So moving from the data and analysis that's sort of led to this understanding of the issue, what data and digital tools is enabling us to do is come up with different policy solutions to meet this new energy system challenge and continue our trajectory to low emission energy. So continue rooftop PV, continue energy efficiency, and all of those good things. And it's the digital tools that are enabling it. So recently we've implemented policies where parties that have rooftop PV actually have agents that are able to remotely disconnect and reconnect their rooftop solar in an emergency. And it's smart meters and it's the inverter technology that's enabling that. And so settings have been changed and have updated to allow that to happen. We're also separating essential load from our non-essential load and generation in our smart meters, which allows a lot more greater control. So it allows consumers to help shift how they use energy to basically make use of that low energy that's in the middle of the day and really shift it out of those peak periods for a better and more efficient overall solution. Next slide. The digital tools are also enabling us to shift our energy efficiency policies. So recently we've moved from an energy policy program that really incentivises just energy savings to one which is now incentivising energy savings as one part, but the second part is rewarding people for how they use energy. So they may not necessarily save energy, but if they're shifting energy from peak to those off-peak and shoulder periods, we're rewarding that. And it's digital tools that are really the enablers that are allowing us to do that. So we're now able to reward people for joining demand response aggregation programs and virtual power plants that are enabled through really control technology, smart meters, and smart inverters and smart appliances. Next slide. But the shift in what we've found is the shift to more digital tools and smarter appliances and more distributed energy resources really requires to rethink how you do compliance and monitoring. And one of the things we've implemented to help with that is electronic certificates of compliance. So we're able to link a lot of our policy to the electrical installers, and the electronic certificates of compliance is where an installer actually certifies that their work is safe and it's complied with our standards and our regulations. It allows our auditors to basically see in real time as installations are completed and to do desktop audits as well as prioritise where they want to do compliance activities to try and make sure this is all being done in a responsible way. This has also enabled us to collect more information about our distributed energy resources that's feeding back into forecasting and planning. So we're able to collect capacity installs, where those actual installations are occurring. That feeds back to forecast and planning with our market operator. And from there, it actually comes back into the policy cycle as we adjust with the trends that they're seeing through their forecast and planning. So I guess if I can summarise, we're seeing digital tools and data as essential to not only that upfront analysis of how your system is evolving as we move to a low emissions future, but also then the policy solutions you'll actually use to address those challenges, and then how you actually make sure that they are being met by your independent industry and your consumers, and you are actually having a safe and compliant environment. So thank you very much.
Thank you, Rebecca. And I think it's important for everyone to see how digital tools will be vital for managing the clean energy transition at very high market penetrations of renewable energy. And South Australia is really a great test case of how those issues are being managed. So thank you for your contribution. I'm now glad to invite Ms. Hannah Green, Director for Energy for the Americas at Microsoft. Please, the floor is yours.
Thank you, Nicholas. Pleasure to be here today. My name is Hannah Green, and I'm the Director for the Energy Industry across the Americas at Microsoft. I've been in the energy sector working on grid decarbonization and resilience for the last 13 years, and bridging the gap between technology, utilities, and the policy that drives these markets is really what animates my career. It's actually what brought me to Microsoft to be an energy person at a large tech company. And I really think that the nexus of policy, technology, and grid management and operations are exceptionally pronounced when we talk about energy efficiency and have these conversations today. I think this portion of the sector, reflecting some of the opening marks earlier, has really shifted, right? And we are entering that golden age. I started my career actually working on energy efficiency, and it was all about demand reduction, right? And alignment, demand reduction of our resources. Now I think we're shifting more towards alignment of energy use with renewable production to really enable that grid flexibility. And that's where we're going to see grid decarbonization take flight. Next slide, please. Microsoft has a longstanding commitment to sustainability. The company has been carbon neutral since 2012 and has set incremental targets for reaching 50% of energy use from renewable resources by 2018 and 2020. And now we're looking out towards that 2025 100% target. By 2030, our goal is for all data centers to be diesel-free, with options including alternate fuels, renewable natural gas, long-duration batteries as well. Microsoft's goal is to be carbon negative by 2030, and actually to remove historical emissions by 2050. You might have seen announcements from Microsoft calling this our carbon moonshot, right? The company is also investing $1 billion in a climate innovation fund towards technologies and partnerships to get there. We know we need all of the technology and digital capabilities we have today accelerated for us to globally meet these goals. And we also need breakthrough innovation. And because of that, Microsoft is using its abilities as a large customer and load to test new capabilities and technologies. You'll hear us refer to it as being customer zero, and using that ability to collaborate and innovate with utility, government, and ecosystem partners. So I'll share a few examples of what those partnerships and innovation look like. Next slide, please. Vattenfall and Microsoft worked together in Sweden to pilot a 24/7 matching solution to supply data centers with renewable power. This was a first of kind trial, and after the successful trial, this is now going to be rolled out across Microsoft data centers in Sweden. So this was a really successful and interesting co-innovation between our companies that sets the stage for more commercial growth. I wanted to highlight this project because it really speaks to me to that real goal that grid flexibility can deliver. And that's true grid decarbonization. I spoke with a commissioner recently of a state in the US who shared that they were under extreme pressure to build and site more renewables and to increase generation in parts of their state. But given their regional load curve and the industries, the heaviest industries that have the highest peaking demand, more renewables, specifically more solar generation, just isn't the right match necessarily for them to meet their carbon goals. Rather, they need the right signals to match the highest renewable supply with the highest load. They need something like 24/7 matching and the constructs and policies behind it to support grid decarbonization. Next slide, please. I'll give another shout out to our colleagues in Australia. And just, we'll again echo the tremendous leadership that we've seen in the Australian market as a go first leader in DER adoption. So delighted to follow your discussion. We are also partnering with the Australian energy market operator AMO and a consortium of energy providers to create a grid simulator for the entire Australian East Coast network and to incorporate detailed models of wind and solar farms and battery storage systems. The goal of having a model is that it can simulate the behavior of these different connected resources, look at things like weather impacts, grid impacts, and ensure that there is a path for the system to be optimized for peak renewable production to meet our carbon goals, and also optimized for security, efficiency, and resiliency. I think this is really a perfect example of a digital tool that supports policymakers, market operators, and that broader grid decarbonization goals across our market. So to wrap up, next slide, please. To realize our vision of a flexible decarbonized grid, we have to have the policy architectures that enable and incentivize these operating models and the adoption of the technologies that accomplish them. We're moving from a one-way power flow and centralized generation to the multinodal grid with distributed power, higher variability of loads from electrified transportation, and really the most diverse mix of power generation worldwide that we've ever seen on any grid. We need grid flexibility at greater scale and at an accelerated pace, and that's going to require three things. First, investment and new kinds of investment. Technology is the infrastructure of this new grid. So one of the things that I look at if I look at market design is, have we set up a system that stacks rewards for poles and wires and more, historical capabilities? Or have we set up a system that rewards lowest carbon, lowest cost, most reliable solutions, whether they're hardware, software, digital, traditional? So I often think, how do we design markets for outcomes? Two, scale. And I'll wrap up here. Pilots that don't progress towards scale kill innovation. So something that this is the entrepreneur in me speaking, who's been in a growth sector. Think about how you launch pilots, test them, because you want to scale successful solutions only, right? But then provide that path to scale and to growth. So you provide a glide path for entrepreneurship and innovation. And third and last, innovation. And what are the tools that you need as decision makers, planners, regulators, policymakers to provide innovation in policy, market design, and regulation over the next 2, 3, 5, and 10 years? I'm excited for that discussion here today and looking forward to hearing some of your ideas about, what are the tools you need, digital twins, scenario simulation, climate modeling to achieve your goals. Thanks.
Thank you, Hannah. It's really exciting to see how big tech is helping drive innovation at the nexus of generation, end users, and policymakers. Last but not least, I'm pleased to invite Mr. Matt Golden, Chief Executive Officer of Recurve. Over to you, Matt.
Thank you. We're going to hear some very common themes, which I enjoy. Go ahead and move to the next slide. But we are a California-based company. We work across the United States, also in Australia, and as well as in Canada, and a little bit in Europe as well. And this is really what's driving our approach to the market, and very much the grid infrastructure and distributed energy needs in the United States, which is we see these carbon goals really stretching across the entire U.S., irrespective of political boundaries, and really driving massive adoption of renewables, which is dramatically affecting load shape. Go ahead and move to the next slide. But in California, we're in particular, and you can go ahead and advance the slide. We're experiencing really volatile load shapes. This is an example from May 3rd this year, which we like to joke that we're no longer a duck curve, we're now a skateboarding ramp, where we're seeing things like a 3-hour, 14 gigawatt ramp rate in the evenings, even after curtailing 2.5 gigawatt hours of grid scale renewables. And so this is really expensive from a grid standpoint, obviously, but also is really affecting our ability to decarbonize. As we really have an over generation of renewables in the middle of the day, and it's really all about shifting, shaping, shimmying load so that we can take that clean energy that we're generating and be able to shift it into the periods of time when we actually need it, which is driven in our environment by a coincidental commercial and residential evening ramp. Go to the next slide. California, we have our duck curve, which actually looks quite a bit like Australia. But driven by solar in particular, but we do see this kind of menagerie of grid shapes and strange animals emerging across the globe, which is just becoming more and more predominant as we accelerate towards our clean energy and decarbonization goals. Next slide. So what we're using digital technology and data for, particularly, is the integration of behind the meter resources in a general sense. We actually believe as a company that energy efficiency is not really a thing. It's actually demand flexibility. It's hourly locational impacts that we haven't bothered to measure. When you insulate an attic, or you put IoT on the wall, or you put a storage system in a garage, for that matter, all of those things affect load shape in a way that we can measure and quantify and value properly. And this is getting increasingly important as demand flexibility tends to be the fastest to distribute into the grid and deploy, also the lowest cost option in many cases, and also has the benefit of helping building owners whether it's residential or commercial, manage the cost of decarbonization by not just supporting grid needs, but also reducing their demand and energy use on site. And one thing that I think is particularly interesting from a policy standpoint in California is that just in the last couple months, we've actually moved specifically where we will no longer have kilowatt hour savings energy efficiency goals. We're moving to a new metric called total systems benefit, which is based on hourly locational marginal avoided cost from a grid stacking standpoint. It is totally possible in California to reduce energy usage and not save carbon and not actually have grid benefits, and also the ability to increase demand. And this is particularly important as we decarbonize and electrify the grid. But if done in a correct way, we can actually see additional demand have carbon benefits and grid value as well. So energy efficiency is no longer a goal because it's no longer true that you can it's always a good thing to save energy in every hour in every location. So next slide. So we've been working for the last decade, in California, but also really across the country in the US, increasingly including the middle of our country politically, which is pretty exciting. Initially developing the tools necessary to utilize smart meter infrastructure and interval data. So, as a company, we deploy these tools commercially. We do that through a SaaS platform to scale and enable utilities to ingest, clean their interval data and actually turn it into something useful. So these tools are all entirely open source. Caltrack and the OpenE meter are actually part of the Linux Foundation. These additional tools, for example, Grid Meter, Energy Differential Privacy, and the Flex Value Engine will soon also be contributed to the Linux Foundation, but also totally open source. And when taken in total, these tools enable us to ingest, clean, and model every single meter endpoint on the grid. So that means that we know which buildings, and you can go ahead and advance to the next slide. At a very fundamental level, we can identify which exact buildings and meter endpoints are affecting the grid. You can go ahead and advance. And actually, the next slide, I think it has 3 builds. You can just build the whole thing. So utilizing these tools and really the ability to automate and parallelize the processing approach, because we're talking about very large scale data and running tens of thousands of servers to be able to process it effectively. But we deploy that really in terms of 3 products that end up in the laps of utilities and also a whole range of companies in the market that are developing business models, pursuing customers, and generating demand flexibility that not only has benefits to the customer, but also has mutual grid and GHG benefits. So having these tools and the ability to parallel process across large cloud resources and automate that for really the first time ever. In our resource planning approach, we have the ability now to model every single end customer on the grid, figure out where exactly are these loads coming from, what sectors, which exact buildings are driving peaks from what end uses. So a grid planner can actually identify which customers need these services, then be able to track in real time the behind the meter resources and understand what they're actually delivering, and then be able to account for that properly and forecast it. Go ahead, next slide. And this is being deployed broadly in a whole bunch of states across the US in a very market-based model, which means allowing the utilities to move away from trying to solve the problem of how to develop technologies and business models, and instead focus on paying for outcomes and engaging what is an increasingly exciting sector of innovative companies developing new technologies. And you go ahead and move to the next slide. So in this model, rather than kind of running a traditional program and determining which DERs and which thermostats or battery technologies are the right outcomes, you can go ahead and advance the slide. The utility is able to be agnostic to the technology and engage this massive sector. And instead of taking that risk up front and trying to predict those outcomes, and you can go ahead and advance the slide, please. These companies that are out building these models, we seem to have missed a slide, that's fine, are then able to deploy their technology and compete in the market effectively, deliver and getting paid for those outcomes that they deliver that we're now able to measure in a standard way. So in terms of the policies that enable this across is first and foremost data access. When you go back, the energy differential privacy logo that was on that open source slide is a tool that we developed with the US Department of Energy, which is something that I think particularly in Europe with GDPR, we have something very similar in California, is a very useful framework for unlocking large scale data. Differential privacy is a very advanced mathematical approach to ensuring privacy, which enables us to utilize this data while also securing individual customer privacy levels. But then also having the ability to in a standard, consistent, verifiable way, turn that raw data into something useful. And it's important that those tools be open and transparent to all parties. And then really transition the model from the approach we've had where we're predicting and paying and trying to solve the barriers ourselves, and instead valuing outcomes correctly, paying for those outcomes, and allowing the market to compete to figure out how do we develop and deliver the business models and technologies to customers, and the customer is the hardest part, in a way that can scale and reward those companies that deliver the most benefit to the grid, so that we see really competition driving the next wave of innovation. And then really shifting energy efficiency, and this is very much starting to happen in which we're really excited about, from government ratepayer surcharge programs that are generally top-down and centralized to instead distributed markets where, rather than engaging policy dollars, we're actually competing as a procurement resource and a hedge against market exposure using flexibility. And this is a much larger bucket of money and represents energy efficiency actually being a resource, and flexibility and DR taking its place alongside supply and grid side resources, which is really exciting. So with that, I'll hand it back, and thanks for your time.
Thank you, Matt. It's excellent to see how Recurve is helping lead the way with some of these open source tools that are available to policymakers and others to really create the metrics and enable the marketplace to scale up energy efficiency to the next level and distributed energy resources. We might just move forward to the next slide, and I'll ask panelists to switch their cameras on to join us for, we probably have time only for one question, unfortunately, and using the chair's prerogative, I might direct that to Rebecca Knights from South Australia. But what, in your view, needs to happen to allow the much greater adoption of these digital solutions that we've been talking about to help policymakers? So South Australia is very advanced along the way in the clean energy transition. And could you give us some thoughts from your experience on the basic infrastructure or regulatory requirements or the consumer acceptance? What in your view are the key things that need to happen to enable policymakers to move to this new next generation of energy efficiency tools? Rebecca. You're on mute. Sorry. We seem to have a problem with Rebecca's connection. Hannah, sorry to put you on the spot now, but perhaps I could direct this question as well to you. You've also worked closely with the Australian markets. And so what, in your view, needs to happen to allow the greater adoption of these digital tools from your perspective?
Sure. I'll just say I wouldn't dare speak on behalf of Australia, its government or its market operators. So we'll put up that wall. But I think some of what you see in their leadership and early moving is are some of those three pillars I called out before. It's this funding, right? Knowing you have a goal and being willing to fund it and to move ahead expeditiously towards it, and understanding that you might need new operating models in parallel with new tools that enable control and dispatch of resources. We simply don't have time to do something, wait 5 more years and do the next thing. You need to make these investments concurrently and have regular workshops and collaboration to true up those markets and make sure you're valuing the right outcomes, as Matt spoke to as well. So fund it, accelerate it, deploy it, test, improve.
Thanks, Hannah. And we could have a much longer conversation, and I'd love to speak as a group at a lot more length. But in the interests of the next session, I might move on to session 2 and perhaps make a sort of a general comment from session 1 is what seems to be clear from many of the examples that we've seen is that there's digital tools are enabling a deepening of the potential of perhaps what we call traditional energy efficiency through tools such as QR codes for standards and labels, but also a real broadening of the scope of energy efficiency and the role it plays in an integrated capacity with a whole lot of other distributed energy resources. So going into session 2, we'll be discussing how digital tools can enhance program monitoring and delivery to enable stronger communication and connectivity with energy users and stakeholders. And I'm delighted to be introducing another inspiring group of panelists here. First of all, I'm happy to welcome Mr. Arijit Sengupta, the Director of the Bureau of Energy Efficiency from the Government of India. Please, the floor is yours.
Yeah, thank you, Nicholas. And yeah, next slide, please. So, of course, I think there is very little that I would like to mention here, apart from the fact that as far as the government of India is concerned, so we have a program to transform India into a digitally empowered society, and that is what the vision of Digital India is all about. And of course, this will mean that digital technologies are therefore emerging to become the integral to the 21st century low carbon pathway that India is talking about. And it will also enable policymakers to meet the energy efficiency targets. Next, please. So as far as the relevance of digitalization to energy efficiency is concerned, I will be touching upon 2 aspects of energy efficiency, where we have been able to successfully implement digitalization to the benefits of the consumers. One is, of course, as far as the appliance scheme is concerned, and the other is the industry scheme that the government of India has. So as far as the relevance of digitalization to appliance energy efficiency is concerned, of course, we have seen that it has really helped us in data collection and management. It has also helped us in tools for data analysis, product registration, monitoring and compliance, and of course, enhancing the awareness and outreach to consumers. Next, please. So as far as the appliance scheme of India is concerned, we have seen how digitization has helped us in product registration system. So we have a dedicated website for it. We also have this kind of information on energy savings and also on the number of appliances in each star band for all appliances. And that for that also we do have a dedicated website for it. We have a policy tool for prioritization of products, and also we have a mobile application in place. So these have really helped us in achieving the desired kind of goal of penetration of more and more labeled appliances amongst the consumers. We also have conducted a consumer behavior study wherein we have got some real-time data on appliance usage pattern, and this is really helping us to support future policy decisions, revisions, and evaluation of the programs. Next, please. So this is how the product registration database looks like. Next, please. So with these 2 things which we have already implemented, that is policy tools and mobile apps. And the third thing, of course, is the QR code, which the government of India is in the process of implementing for its appliance labeling program. So the advantages are manifold. So of course, the first advantage is that we are seeing a selection and prioritization of products, projections or market growth. Then of course, we also have seen the estimation of energy savings potential, which actually have helped us in coming up with future products. We have also seen how that it has enabled us to support data acquisition, handling, and also it has provided the labeled appliances data in accessible manner, and also a household specific recommendation service on how to save energy. So these are all the advantages which we have seen to a certain extent. And with the future implementation of QR code, I think we will be able to get all the advantages in a more holistic manner. Next, please. So this is how the Bureau of Energy Efficiency stall leveling mobile application looks like. Again, just a representative, a screenshot from the web page. Next, please. So this was all about the appliance labeling program. And the next 2 slides, I am just highlighting how it has benefited the industry program of the Government of India. So we have a very successful program.
Sorry, Arijit, this is a fascinating presentation. If we can begin to bring it to a close, and perhaps we can come back in the discussion to some of these points, if you don't mind.
Thank you. Thank you. Thank you very much.
Do you have any? Okay, thank you, Mr. Arijit. Next, I'm delighted to introduce Dr. Ashok Sarkar, Senior Energy Specialist and Task Team Leader for Energy Efficiency Projects at the World Bank. Please, you have the floor.
Thank you very much, Nick, and thanks to the IEA and Brian Motherway and others to have invited me for this session. Let me again start my presentation by giving a little bit of a big picture based on the energy efficiency policy experiences which we have had and how digital revolution has really changed the whole ecosystem for energy efficiency, particularly on the demand side. It's in fact been covered by many of the speakers like Gabrielle and Rebecca and Matt and Hannah about the details of what has been applied and how technologies have really become an inherent part of the energy efficiency, renewable energy, and clean energy landscape. From my perspective of doing about 25 years of energy efficiency work, I really feel that digital transformation has addressed the fundamental barriers of energy efficiency. What we saw as barriers a decade ago or 2 decades ago of energy efficiency being small and dispersed, dealing with multiple stakeholders, unlike large power stations where you deal with only 1 or 2 stakeholders. Again, solutions being very dispersed and diverse because one size does not fit all in energy efficiency. When you talk about LED lights versus motors versus demand response with large industries, they're all different solutions. Because of that, the transaction costs have been higher. And that was the fundamental barrier we were facing in the energy efficiency ecosystem. That is the lack of data and the transaction costs. And as a result, we were not able to measure, analyze, and communicate as effectively as we would like to do when it comes to energy efficiency. As one of the speakers earlier said, fundamentally, energy efficiency is cost effective, but it's still not being done. Not being done because it's difficult to sometimes measure and document. Sometimes it takes time to analyze, it takes money to analyze, and sometimes it's difficult to communicate, as we saw in the early days of energy efficiency when it started 20 years ago, that many of these digital tools didn't exist. As a result of all the computers and connectivity and sensors and data and all kinds of software, which I'm not an expert of, but I am a beneficiary and a user, what we have seen is that it has started addressing some of these fundamental barriers of energy efficiency landscape. And that has really resulted in the policy and the program implementation, monitoring and evaluation much more easier, much more cost effective, much more faster. And that's what is really shifting the needle for efficiency and with the integration of demands, digital revolution, digital transformation. Let's go to the next slide, please. So again, just to tell you that based on what we have seen in the OECD world and what we are seeing in emerging economies, Arijit talked about India, but there are other economies in the developing world context which are doing equally well. And why? Because they are very good with policies and regulations, the institutional framework, financing, awareness and information, and technical capacity, what we call the 5 pillars of energy efficiency to make successful programs out of it and to have real savings. And in all these pillars, what is happening is that the digital tools, which we talked about in the previous panel as well as in this panel, have been integrated in a manner that they make these policy regulation, financing, etc., much more easier to do now, much more cheaper to do. And again, we're not going to get into the details of how big data and artificial intelligence and smart meters, all that can be done. I mean, those are technologies. Technologies have been in place, but to combine the technologies to actually apply to policy implementation and policy impact analysis is where the art of integration of digital tools come in, and this session is therefore very, very important. Let's go to the next one very quickly, please. So just to give two examples, and I know India becomes a very common example in some of these sessions. Being an Indian, I'm proud of what India has achieved, and therefore let me take the liberty of explaining what happened beyond what Arijit explained. So in India, in last 4 years, they have deployed over 360 million LED light bulbs to replace incandescents and CFLs. Now, believe me or not, each and every one of those light bulbs can be tracked as to who used it, which consumer, which bill number, which state, which city, which part of India, when did they get it, how much are they saving. Now, all that monitoring at the policy level with 360 million light bulbs, it's only possible because of the digital revolution. So what is happening is that these tools are allowing the country to actually measure the impact real time. Believe me, if you go to this website, which I've shown on the right-hand side, this number changes, which means every 10 seconds, it updates on who bought a light bulb where to replace an incandescent lamp and measures the impact. Now, the impact shown here is almost 10,000 megawatts of peak load reduction, 9,553 megawatts, CO2 reduction and all that. So imagine the power of this digital revolution, how this has transformed the market in India. Let's go to the next one, please.
Exactly. If I can just ask you, perhaps.
Let's go to the last one. Let's go to the last one, and I will wrap up. So what we are seeing is that the future of the energy system is really unlocking and bringing in more opportunities now through digitization. I call it the 5 mega trends, the Ds: disruption, decarbonization, decentralization, democratization, and digitalization. I know the Chile speaker, Gabriel, talked about 3, and I wanted to add 2 more to that list. Why? Because the black part of this figure shows the old system, and all the red part, which includes prosumers, consumers, which Hannah talked about, have really opened the door for energy efficiency in a way that we have not seen in the past 2 decades. So I think this is a very timely session, Nick, and thanks for organizing this. We really need to work together with the digital experts and the efficiency people like us to bring the best of the 2 worlds to actually help the net zero 2050 scenario, which you guys have very nicely articulated. And thanks again to IEA for really bringing everything together. Over to you, Nick. Thank you.
Thank you, Ashok. And it's really encouraging to hear from somebody who has been involved in energy efficiency for so long, to hear how digital tools have enabled overcoming some of these barriers that we've been talking about, it seems, for decades, by making the benefits of energy efficiency much more transparent and possible to manage. I'm glad to invite Dr. Ronita Bardhan, Assistant Professor of Sustainability in the Built Environment and leader of the Sustainable Design Group from the University of Cambridge. Ronita, the floor is yours.
Thank you, Nick. Thank you so much for the kind introduction. Next, please, I'll go directly. So briefly before going to what I'm going to speak today, broadly, I will explain what I've been working on. And in our group, we work on these 4 major verticals of the Sustainable Development Goals, where we focus on the interlinking between energy efficiency, health and equality, and sustainable living. And also major focus also came up in very recent studies is gender. Next, please. Broadly, we use data and we see data as a solution because we feel we just not look at the data, which is very under the normal curve. We try to look at the outliers because we primarily find that's where from the occupant behavior side, energy behavior or usage kind of becomes more and more prominent when we look at the outliers. Next, please. So I'm going to talk a bit about what's happening in Mumbai. I've been working on Mumbai for quite some time now, and it has been a very fascinating space, not only because of its complete contrast in population, demography, and economy, to say the least. Around 65% of Mumbai's population live in cramped and slum or slum-like situations, where probably disease and energy transitions are very complex. And next, please. And now I'm going to show to you what's exactly happening in the landscape of Mumbai is that based on the newer policy frameworks of providing affordable housing to major population in India, they're replacing slums, and that's a very good thing. What's happening is, next please, these slums are being replaced slowly by high-rise towers, which will be affordable housing and are given free of cost to these slum dwellers. Next, please. And here you can see as we move from 2000 to 2005, the buildings are being built and a part of the slum has been cleared. And next, please. And this is an image, next, please. And this is an image from 2017 where you can see that probably a neo-informality is probably emerging, and it's a very new typology of built environment that is being created. These are all houses and domestic households, which will generate a new form of energy transition, which is yet to be kind of discovered at a larger scale. Next, please. So in order to understand the energy transition in such a diverse and different sort of a place and a new sort of a household typology that is being coming up, when people move from these horizontal living to a vertical living, definitely aspirational energy use comes into play, and also probably some of the dysfunctional housing designs also maybe contribute to the energy transition in very peculiar ways. And to understand that, next please. We started looking at different sorts of digital tools to understand what's exactly happening. So we started looking at gender mainstreaming. It's primarily because we found out that women in these houses almost spend 90% of their time indoors, and unlike what they would have spent outdoors when they were in the slums, they are kind of restricted here because of lack of association to the ground, and also there has been a lot of breakage in the social network, and that has led to not only aspirational buy of and usage of energy appliances, but also because of loneliness, brokerage of social network, there's been a push towards the uptake of large amount of energy intensive appliances. Contrary to the belief that being the poor and belonging to the bottom of the ladder in the energy ladder, probably they use the least amount of energy. But when we see it relatively in these sort of circumstances where the large portion of the population is being displaced into these sort of houses, probably understanding energy dynamics from not only the usage perspective, but also gender perspective becomes very important. So we have used digital tools like sentiment analysis to understand what exactly goes in when a woman starts using the energy in these spaces. So one of the primary things which we have understood is that getting the data, the high resolution data of energy use in these sort of houses becomes very, very difficult because getting intrusive sensors into these houses becomes a very big challenge. So we started looking at alternative and novel data sets like films, which represent these sort of houses. So here you can see one film which was completely shot in these sort of houses, and we tried to extract information. Similarly, we did it with health, and during COVID, we tracked how data information was happening and how energy and health had a very strong nexus. We could find out that women are generally in more distress than men. I don't know whether it's a surprise or not, but their energy usage for comfort becomes, there's an asymmetry in the energy use of comfort, primarily because of the agency of buying an energy appliance lies on the male gender, whereas the usage primarily lies on the female gender. We've also used satellite images to understand how we can normalize the energy demand that is being rising from the not only the usage of energy from these sort of peculiar transition, but also from the heating climate. Thank you so much. And I would just like to introduce, last slide, please. We have started a new program where you're trying to look at data and to understand effects of epidemics on energy and health. And if you're interested, please go to the site and you'll get more information on that. Thank you so much.
Thank you, Dr. Barden. And that was a very visual presentation, which I think showed quite well how digital tools can be used to provide policymakers with much better information around some of these social and gender issues. And perhaps we can come back to some of this in the questions. So thank you for keeping your presentation within the time limit.
Thank you, Nick. Thank you, Nick.
I'm now pleased to welcome Professor Taj Ostrizan, who's Director of the Smart Energy Research Lab, University College, London. Please go ahead, Taj.
Thank you. I would just like to very briefly introduce two digital tools for helping decarbonize the built environment. And the first one I'm going to be talking about is the Smart Energy Research Lab, which uses smart meter data. What we have built is an observatory of a representative sample of 13,000 homes across the UK. These all have smart meters. About 40% of homes at the moment have smart meters, and we're due to roll out to 100% over the next few years. We've linked that data to the local weather data for each of the homes, and also the energy performance data, the energy performance certificate that is available for those properties. And then in addition, we've collected a survey of questions on the dwelling occupants and their attitudes, so that we have the energy data, but also the contextual data about the weather, the energy efficiency appliances, and the occupants. Next slide. The next tool I want to talk about is a digital twin that we have built. And we've set up utilizing existing data sets. So we believe that it's important not only to collect new digital data, but where data has already been collected. And very often for reasons other than decarbonisation, that data has been collected, to utilize that to its maximum. And we've done that, putting together a whole range of available government data sets that enable us to build a three-dimensional model of every building, to use data from the valuation office to identify what is happening in that building at every floor level, and to link that again with energy performance data, the certificates that are created for buildings, and other contextual data. And for special purposes, the UK government allows us to link individual gas and meter data at property level. But in this case, it's not smart meter data, it's annualized data. So it's the whole year's worth of data. Next slide. So we've built a three-dimensional model of every building inside of London. And we're in the process of rolling that out to the whole of the UK. And that model here is of central London. You can see St. Paul's in a turquoise colour. It brings all of those data sets together. It enables us to know what's happening within each floor of the building. And even within a floor, you might have a building which is classified as an office, but part of it is a kitchen or a store. We know the percentage of floor area that is allocated to those different functions. Next slide. And so this model has been built for the Greater London Authority that plans for the decarbonisation of London. And they're using this data for a whole range of different policy initiatives, from fuel poverty to persuading people who rent out properties to upgrade their properties, to identify poorly performing buildings, and to try and incentivize the refurbishment of those, and just plan the decarbonisation of London as a whole. Next slide. So here you can see one way in which you can cut and slice this sort of information. This shows the percentage of glazing improvements that can be done on the left-hand side, and you can see that there's more potential for glazing improvements in the centre of London. Then wall improvements go slightly outside, and the perimeter of London is more prone to be accessible for roof improvements. Next slide. Because we have the shape of every building, including its height and the adjacent trees and spaces, at a resolution of 0.5 metre by 0.5 metre, it enables us to calculate the solar opportunity. And we have created a solar opportunity map, which GLA are looking to help them decide where to best install the 2 gigawatts of photovoltaics that they're committed to installing. And the model not only knows the orientation of each roof, but the degree of overshading from trees and from adjacent buildings, and so can maximize the potential generation from PVs by correctly installing them. Next slide. So other applications, there's a lot of research applications to these sorts of tools that we've built. We've been able to say that the energy performance certificates are for some buildings not particularly accurate in predicting the actual energy consumption, and that's allowing us to develop new energy performance certificates, some directly generated from smart meters. It's enabled us to look at high-rise energy use in buildings, and the graph that you can see there shows that 6-story buildings use half the energy that 20-story buildings do when normalized for floor area. And so high-rise buildings are energy inefficient. Our smart meter data is allowing us to work out what's happening post-COVID in terms of energy use, our change in behaviors, working more from home, less in offices. It's enabling us to produce building passports, to provide local planning tools to help determine where skills are needed, materials, and heat distribution systems. And for national policy, it's particularly good for evaluation of policies. Smart meters in the UK store 13 months of historic data. So if you recruit somebody into refurbishing their home, you get their historic data before the refurbishment as well as the energy consumption afterwards. Last slide.
Well, thank you, Professor Taj. We might just skip ahead very quickly in the interest of wanting to have a bit more of a panel discussion and also hopefully involve some of our online audience who I know are there, and thank you for your comments. If you don't mind, we might just skip ahead now to introduce Mr. Ian Maddock, co-founder and Chief Revenue Officer at MyHeat. Please go ahead.
Thank you, Nick. Hello, everyone. MyHeat is a Canadian technology company focused on making energy visible through remote sensing and high-resolution heat maps derived from complex algorithms and machine learning. On behalf of the MyHeat team, I'd like to thank Nick and the rest of the IEA team for the opportunity to tell you a little bit about MyHeat today. As you're aware, approximately 19% of the global emissions come from buildings. Based on building emissions inventories disclosed under the C40 initiative, MyHeat estimates that if our technology was scaled to a global level, we would have the ability to drive 0.5 gigaton of annual emission reductions. The next slide, please. At MyHeat, we build tools that make energy visible to global citizens. Our imagery provides a powerful nudge that helps drive energy efficiency program uptake and makes a lasting contribution towards building emissions reductions. I'll just ask that you queue up a quick 90-second overview video to explain our technology.
Everyone knows some basic ways to save energy, but when it comes to heat loss, most people don't know where to start. How can you fix something you can't see? That's where we come in. We help utilities and government agencies around the world meet their efficiency goals by making heat loss visible. Studies show that when people are able to see and compare their heat loss, they're motivated to do something about it. Our award-winning technology uses thermal images of rooftops to pinpoint areas of heat loss across entire cities. Our heat maps show areas of a building that are losing the most heat in red and more efficient areas in blue. Based on the amount of heat escaping, buildings are given a score of 1 to 10 and shown how they compare to others in the community. Buildings rated 6 or higher are the best targets to help you combat energy poverty, reduce consumption and greenhouse gas emissions, and improve energy literacy. We share the personalized imagery through private online profiles with partner-specific branding. These profiles help owners better understand their heat loss and instantly connects them to local efficiency programs and services. Our partners are using this information to motivate hard-to-reach customers, boost program participation, change behaviors, manage peak load, and mitigate the need for large capital projects. Let us help you implement a remote, turnkey solution for residential or commercial use in as little as 3 months. So let's get started. Book your free demo today to see the impact Energy Made Visible can make.
Thank you for that. And if you could just queue up our next slide. And what makes MyHeat different from others that have created building thermal images in the past is that MyHeat combines that high resolution remote sensing data with machine learning to create individual heat maps and heat ratings that was described in the video there for each residential building in a city. The buildings are rated with that 1 to 10 that was mentioned in the video, with 10 being the highest heat loss. Next slide, please. For countries, MyHeat can create a thermal atlas with city-scale heat maps for all cities and towns in a country. Individual heat maps and heat ratings would be created for each homeowner. Governments and other stakeholders can use the data to target the least efficient homes in cities across the country. Having a strong engagement plan will help countries stay on track and ultimately meet their building emissions targets. Improvements in buildings' thermal efficiencies can be tracked over time with additional data collections. Next slide, please. Data from multiple cities across the country will help policymakers target the cities and homes that need the most improvement in building efficiency. And comparing cities to one another will promote a healthy competition as we all work towards a greener future. Next slide, please. And from a homeowner journey standpoint, each homeowner would receive a password protected access to their own homepage that would show their personalized heat map, their heat rating, how their home compares to similar homes in their city, and calls to action with links to the efficiency programs and rebates. Next slide, please. And government and other stakeholders can use MyHeat's engagement platform to combat energy poverty, reduce building emissions, get funding into the hands of homeowners that need it the most, and track the thermal attributes of your nation's building stock over time. With that, thank you very much for the opportunity to tell you a little bit about our company.
Hey, thank you, Ian, and thank you for this example. I know we're going through a lot of case studies and experiences very quickly. Our goal is to give a wide range of examples from different countries around the world very quickly, so people who are interested in a particular aspect can follow those leads along the way. We have one more presentation in this session, and I might just request that our online audience, if you have any questions or comments, please bring them forward to us via the chat option. We should have some time to explore these in the panel discussion coming up. So lastly, I'm pleased to invite Dr. Domenico Palladino from the Energy Efficiency Division of the National Agency for New Technologies, Energy and Sustainable Economic Development from the Government of Italy. Domenico, the floor is yours.
Good morning. Thank you so much. It's my pleasure to show you some results of IEA that we have a purpose to help the technician of country. We developed two specific tool, two specific app that you can also download on your tablet or smartphone if you want, and they allow to carry out a preliminary energy audit and preliminary seismic analysis of buildings. The idea was to develop a tool able to make easier the collection of data during the inspection of buildings and for the technician, and to provide a simpler tool for energy evaluation, preliminary energy evaluation. it's important to point out some aspects. First of all, these two apps are related to two kinds of buildings. The first one, SIP School, is available only for the school. The second one, Condomini Plus 4.0, is only for building with a centralized heating system. The second point is that this kind of apps are only for preliminary energy audit or seismic analysis. They don't substitute or replace this kind of analysis. The next slide, please. Here, I would like to show you only some overview of the app. It's very easy. You can put on data on specific icons, general information, and the one related to the seismic or energy analysis. The next one, please. And specifically for the energy analysis, we have to insert all the data related to the buildings and the technical building system, starting from the building envelope properties and dimension, and from the power and the kind of heating system or technical building system. The next one, please. Finally, once insert all this information, the app allows to calculate two energy indicators. The first one is related to for the heating, the second one for electric energy. And based on these two indicators, the apps return also the a sort of quality level of the building, which indicate if the buildings should be improved or not. These values of the indicator is based on a statistical value of the same typology of building. For instance, for the school, we have a sort of database of thousands of schools. So we analyze the data in this for the define the quality. The next one, please. Based on this data, it's possible to also provide some technical improvements to be made to make for the buildings to improve the energy efficiency of buildings. But it's important to underline one thing: it's not energy audit; it's only preliminary evaluation, preliminary energy evaluation. So the app doesn't make a sort of calculation, but it provide a sort of statistical intervention improvements that we can do for obtain energy efficiency of buildings. Another critical issue of this app is related to that all the information that we need to insert is technical data, technical information. So the two apps were born for the technician, not for the all the customers. However, it can be used easy for all the customer, but we have to check the quality of the data inserted. The next one, please.
I can ask you to begin to wrap up. Thanks, Domenico.
Okay. Finally, you can, if you want to check or give more information, you can download the app from this link. Thank you for your attention.
Thank you very much. And if I can ask our panelists to join us on the online. And my first question, and I see we have some questions also coming in from the floor, but my first question is to Mr. Arijit Sengupta. I know that several other countries have looked to India's example in using energy dashboards and other digital tools. What are some of the key lessons learned from your experience and for governments looking to adopt a similar a similar approach. And thank you for joining us again.
Yeah, so thank you, Nicholas, and thank you. Mentioned in the presentation as well that the government of India, we are looking to digitize as much as possible, and also in the energy efficiency front, I have highlighted about the efficient way in which we are trying to digitize our standards and labeling program, which is a highly successful program. And of course, Dr. Ashok Sarkar has also highlighted about the Ujala program, the LED program of the government of India, wherein through a dashboard we are able to disseminate a very rich information to the consumers. And the other thing which of course I could not finish in my presentation, that was the industry part. In industry also, we have a very successfully developed our dashboard and the web portal, that is the PATNet portal, and wherein we are getting information from all large energy intensive industries regarding the energy consumption, regarding the fuel usage, regarding the specific energy consumption, and there are rich sets of data that we are also kind of getting on these aspects as well. So, and of course, these are enabling us to formulate future policies in all areas of energy. Thank you.
Thank you, Mr. Sengupta. And Matt Golden, if you're still with us, excellent. We have a question for you from the online audience. Could you provide names of the open source software for the energy efficiency calculations, and perhaps talk a little bit more about the open source dimensions of your work? You're on mute, or we can't hear you.
Double muted, my apologies. I'll be happy to post a link as well that goes to a page that has links out to all of the code repos. But the tools that we've developed really starting about a decade ago, and fundamentally the reason why these tools are open source is as we utilize data, especially to clear transactions on the grid, where we need transparencies and confidence in our output from these relatively complicated calculations for grid planners, regulators, and actually aggregators and others that are financing and investing in these cash flows. We need standard weights and measures, right? We can't have black box calculations that we ultimately are betting on these outcomes from. So open source has been baked in from the very beginning into our approach to the market. We think you can't have a market where you don't have a weights and measures in place. So the tools, and I'll just kind of go through them quickly, but then like I said, I'll post a link where everyone can explore them at their leisure. The CalTrack and OpenAE meter tools, and again, there's a set of methods that are open and transparent. How did we arrive in a consensus process at the methods that are being deployed at a level that can actually be reproduced in a very specific set of methodological approaches, and then translated into Python-based open source code. How do you implement those methods in a standard way? And all of that being available to all parties without restrictions. So the CalTrack and the OpenAE meter tools utilize data from historical data to generate a model for each customer that allows forecasting and baselining on an hourly and locational basis. So how does a building respond to weather and occupancy conditions using interval data as the basis for that modeling? It's surprisingly accurate, actually, in terms of being able to forecast demand for each customer. Grid Meter is a open source library that we developed with DOE funding earlier this year that generates comparison groups from population data that we can use to normalize for exogenous factors, including things like COVID. And that's actually what it was developed for, is how do we actually do measurement and verification through the mother of all exogenous events, something along the lines of COVID, which we're able to do. And then from this audience, I think actually from a policy standpoint, two of the more nerdier but more important areas, energy differential privacy is another DOE funded privacy tool that I would highly recommend folks look at. Differential privacy is a very advanced privacy technique that can actually navigate things like GDPR, allowing us to use population data while rigorously protecting the privacy of individual customers. And then the last tool is something we call Flex Value Engine, which is a tool that houses price signals, calculates the value of flexibility against those price signals, and also can incorporate things like cost effectiveness calculations, so that we can actually track not just the impact to the grid, but what things are worth on a real-time basis. So all of those tools, the methods and the code, are wide open, available to all parties without restriction. And then as a business, like I said, we implement those at scale, but everybody is encouraged to get involved and utilize these tools that are wide open. And I'll go ahead and post a link in the chat if anyone wants to explore in detail. Thank you.
Yeah, thank you, Matt. That's great. And I might direct the next question to Ronita. And thank you again for your presentation. I'll follow that up with another question, which I'll put to the all panelists from first session, if you're still there, and the second session, a question from the audience. But first, the question for Ronita is, in your view, how can governments use digital tools to foster a more participatory approach to policy? And we know that this is key for consumer acceptance of digital tools, and also for program effectiveness in delivering what policymakers want to achieve. And digital tools do offer this solution to better target the issues, particularly around maybe vulnerable groups and gender dimensions. So I'll direct that question to you, and then perhaps just a final question that's to all panelists, if you can think about this afterwards. From the floor, is there any example of independent studies of the impacts of digitization on both the annual energy consumption and on the load curve? So I'll let you think about that while we go to Ronita. Thank you.
Thank you, Nick, for pointing towards that direction, because major part of the work which we have been doing is to understand energy asymmetries, especially in the vulnerable groups, and especially in a gendered perspective, how we can capture that at a scale and more independently and more, I would say, more democratically, and also decolonizing the whole process of understanding energy use. So what we have done very recently is trying to analyze policies using digital tools like from social media, gathering tweets, or understanding through participatory programs like roundtable conferences, where we bring in all the stakeholders, gather their narratives, and then try to find out whether the sentiment of a particular policy, be it energy efficiency or how uptake of appliances, can become more democratic. And we try to understand what makes a person choose a particular appliance and why. And when we did that through this whole dialogue process, we had this corpus of information which we processed through a digital tool which we had built based on AI and natural language processing. We found out that often a very good policy, like a participatory policy where people are involved at the very beginning, they are not aware of the total consequences of their choices. And I trust that if they were involved at the very beginning, of where they were more informed about the consequence of their choice, and that can be easily done through these digital tools which we have developed, to understand why they uptake an energy appliance, or why would they choose an energy efficient appliance, especially in the vulnerable groups. Then it becomes much more clearer to a policymaker. They can have a choice set that if they create a certain set of policies, probably that might lead to a certain consequence. And that takes into account the occupant behavior, the occupant understanding, and also practices, social cultural practices that evolve as people transition from one particular familial type to the other particular familial type, or move from a particular space to a different sort of living. So those are very difficult to capture, and with digital tools, I think that becomes much more easier. Films have been a fantastic digital tool to understand how energy is being used, especially in such spaces where it is difficult to get it monitored. And it's also, so looking at novel data sets and trying to inform policymakers through these digital tools becomes much more easier, in the sense that everybody participates in a more democratic fashion and also knows the consequence of a choice.
Thank you, Ronita. And that's, I think this is an area that I'd invite colleagues to look into, and perhaps explore some of the links in your work in some more detail. So do we have any takers from the panel on a question which really seems to relate to the energy consumption from digital devices, from the digital technologies that support this transition? that we've been talking about. I know this is a question when it comes to the environmental sustainability of cloud, of data services, digital services, and data centers. Do we have I don't know if Hannah Green from Microsoft might have a view on how Microsoft is handling this, if you're still there. I don't see any hands. Hannah, would you be able to give us a view on the sustainability dimensions of the actual digital technologies themselves?
Yes. I guess there are a few pieces there. Sustainability is core to all of our deployments in this space, and we think that technology is the core pillar to achieving our sustainability and carbon outcomes. We also recognize that data centers and technology inherently use energy, and so you have to move both together at once. It's part of what I discussed in the presentation. Microsoft has a carbon neutral and even carbon negative commitment. And a large part of that is matching our energy loads with renewable resources, and then also ensuring that our scope 1, 2, and 3 emissions are covered, accounted for, and that we're part of the energy transition, also using our technology tools. So there's this deep interweaving and integration of both of those pieces.
Thank you, Hannah. I see a hand from Ashok. Over to you.
No, I think answering that question, a very important question about what is the impact of digitalization on annual consumption and the load curve. Yes, there is a lot of analytics and studies and reports, particularly in the what we call the automatic metering infrastructure, smart metering data. The impact of smart metering on the utility system has been very well documented in terms of how the load curves have come down. The load shapes have changed because of the better communication and better data analytics driven by the smart meter platform. As you know, India, for example, has a plan for 250 million smart meters. US has smart meters all over. Even Saudi Arabia, where we work a lot, in fact, has deployed 10 million smart meters in 1 year. All that digitalization is really aimed to bring down the energy consumption and the load shape changes and the load peak loads, particularly in some of these systems. And that is very well documented. We also see the digitalization documentation very well done in the electric mobility space with V2G, vehicle to grid and vehicle to home systems, and how that platform of digital technology is helping bring down the load curves and integrate even renewables into it, because you can charge cars when the sun is up there without affecting the load curve, as Matt was talking about. And I think Hannah and others also talked about a little bit about the integration. So there is a plenty of documents. I have seen a few documents recently. In fact, there was one done by IEA as well 3 years ago, I believe, which captured some of the case studies. So I think we should be able to provide as a group some of these resources to the particular person who asked this question. Over to you.
Thank you, Ashok. And I'd like to bring this panel to a close at this point, just to allow some time for concluding remarks from my colleague, Vida Rosite. And I might point out that we'll be able to follow up on some of the elements of this discussion in some future IEA work. So we might be able to address some of these issues there, but I won't talk too much about that yet to steal my colleague Vida's thunder. And so without any further ado, I'd like to thank our panelists and hand over to my colleague Vida to summarize and conclude. And so long from me. Thank you very much.
Thanks so much, Nick, and thanks to all the participants today. It's been a really interesting and insightful discussion, and I'll not even try to summarize all the topics that have been covered. It's been very rich, but I will take this opportunity to highlight some of the aspects that were covered and mentioned And that really resonated with us. So you've shown us that digital tools can effectively facilitate policy making and implementation across sectors. And even more excitingly, that digital tools can enhance the efficiency of systems and enable policymakers to develop new types of policies and innovative policies and approaches, and to promote more integrated solutions that, again, unlock greater energy efficiency potentials. As was mentioned today, digitalization is changing the whole energy efficiency ecosystem, and it allows us to overcome fundamental barriers to scaling up implementation, which really resonates with what Brian was saying at the outset, that in order to progress on our clean energy transitions objectives, there's a need to massively scale up energy efficiency implementation. And of course that digitalization can help us overcome those barriers that have plagued energy efficiency in the past, such as lack of data and the high transaction costs. And then moreover, the clean energy transition in combination with digital tools is expanding and transforming the concept of energy efficiency. So even beyond the concept of energy efficiency first, to energy efficiency continuously as an integrated part of all aspects of transition. And as was mentioned in this discussion, the importance of finding continued ways of aligning energy efficiency with renewables production so as to extract the greatest value, and in terms of both carbon dioxide emissions, but also overall benefits to the power system, to the energy system, and for end users and consumers. And this is something that we also see reflected in the upcoming IEA G20 report on energy security, where for the first time ever, energy efficiency plays an absolutely fundamental role in ensuring energy security going forward. And an important aspect to highlight is that there are, of course, challenges associated with digitalization in terms of cyber resilience, data security, as well as, very importantly, the need to ensure equitable access to technologies and services. And as we heard today, there are also great opportunities to use digital tools to counteract inequalities. And that's an area that we at the IEA also hope to be able to explore further. And as Nick was mentioning, in a few weeks' time, we'll be launching the article, Better Energy Efficiency Policy with Digital Tools. And this will provide insights on why and how governments are turning to digital tools to strengthen the policy cycle, from design, implementation, and monitoring of energy efficiency policies. And we'll be also showcasing many of the great examples that we've been hearing about today in this article. And so just once again, thanks for participating. And as Brian Motherway mentioned at the outset, this topic is an area of growing importance for the IEA. And I'm extremely pleased that we have such a strong community of experts that we can continue to engage with and draw upon to support our future work in this area. So with this, I'd like to thank you all very much and to close this workshop. Thank you.
Thank you for hosting.
Thank you, Vida.
Thank you very much, Vida.
Thanks, Asha.
Thank you, Vida.
Thanks, everybody. Have a good day. Thank you.
Thank you.
Great day.
Bye,
Thank you.
Brian. Bye. Thanks to
Bye-bye.
IEA for organizing this.
Yeah.
Bye-bye.
Bye.
Thank you.
Bye.